If a cone has a height that remains 3 times its radius and the volume is increasing at the rate of 54 pi inches cubed per hour, at the instant that the radius is 3 inches, find the rate at which the A, radius changes, B, height changes. Let's write down all the information we're given. We have, first of all, that the height remains 3 times the radius. We also have that the volume is increasing, and therefore it's a positive rate v prime or dv dt, positive 54 pi inches cubed per hour, and we're given that the radius is 3 inches. For part A, we want to find how the radius changes. We have the rate at which the volume changes. We need to relate the volume to the radius. For a cone, the volume is 1/3 pi r squared h. Since h is related to r, we can plug that in now. H equals 3r, and volume will become 1/3 pi r squared times 3r. The 3 can move out front with the 1/3, and they multiply to be a 1, so they cancel each other out. So our volume for this type of cone will be pi times r squared times r, which will be pi times r cubed. There's our related variables formula. We can take the time derivative to get our related rates formula. The time derivative of both sides indicated by a prime on both sides. Every variable is implicit with time, so every variable will get a prime when you take its derivative. The derivative of the left side of v is a 1, but then times v prime due to the chain rule. And on the right side, we'll bring the 3 down, multiply it with the pi for the power rule, subtract 1 from the power, and then multiply by the derivative of the inside, which is an r prime. We can now plug our numbers in. We have a 54 pi for v prime equals to 3 pi times r squared, which is 3 squared times r prime. So 54 pi equals to 3 pi times 3 squared is a 9 times r prime. 54 pi equals to 3 times 9, which is a 27 pi r prime. We can solve for r prime now by dividing both sides by 27 pi. The pi's can cancel, and 27 can divide into 54 2 times. So r prime, or dr dt, is equal to 2. It'll have units of length for radius. Length in this problem is measured in inches per unit time, and time in this problem is measured in hours. For part B, we want to find how the height changes. We have the rate at how the volume changes, and we have a rate at how the radius changes, and so we can use one of the two to relate to height. Either one would work, though the relation between height and radius is simpler. That was given to us over here. Its height is 3 times its radius. So we can start with that related variables equation, take the time derivative of both sides. On the left side, we have the derivative of h, which is 1, but then times h prime to complete the chain rule. We get a prime on every variable, due to every variable being implicit with time. On the right side, the derivative of 3r is 3, but then times r prime, since r is implicit with time as well. We can now plug our numbers in, and we have h prime is equal to 3 times r prime we had just found to be a 2, so this comes out to a 6, and therefore h prime, or dh dt, is equal to 6. It'll have units of height, which is a length measured in inches in this problem, over time, which is measured in hours in this problem. So h prime will be 6 inches per hour.